Good morning once more. We want to go through lab 4.1. It's on configuring static routes and default routes. The objectives of this particular lab is to configure static route using an interface and an IP address as the next hop. Also to verify static route operation, to implement the interconnection between a local and an external network using a default route, and also configuration of a backup static route on a router. So that is what we want to do. Generally, our topology consists of 3 interconnected routers. And each of the routers is also connected to an external network, which is simulated using the loopback interface. So remember, the loopback interface is simply a virtual interface. So this particular loopback interface is simply simulating an external network. So it's an external network because it's not directly connected with any of these other routers. So in order to save on time, I've already implemented the topology on ENSP, and I've also labeled it, as you can see. So remember, these ones on loopback 0, they are simply labels. So it simply means that we're going to configure a loopback interface with this IP address on R1. Similarly, on R3, we're going to configure a loopback interface with that IP address, and on R2 with that IP address. So I hope that is clear. Okay, so if we go through task number 1, task number 1 is simply performing the basic system and IP address configuration, that is changing the name and also configuring the IP addresses, which I have already done. So I'm simply going to use the command display IP interface brief so that we can see that I have already configured the correct. We just confirm that I've configured the correct. So that's why I'm making my that's why I make my my CLI translucent so that I can be able to confirm from the topology in the background. So if I do display IP int brief, okay, I think someone's mic is on. Sorry about that, Hillary. I think we're hearing your conversation. Okay, I've been able to mute him. Okay, so in R1, if we do display IP int brief, we can just confirm that gigabit Ethernet 0/0/0 has been configured with the correct IP address. As we can see in the background here, we are supposed to configure it with 10.0.13.1 here. The other one is 10 gigabit Ethernet 1/1/0. We've also configured it correctly, and we've also created a loopback interface. So you can see that the physical status of these 3 is up, and also the protocol status is up. So if we go through this display IP int brief on R2, so we can again confirm that we have configured the correct IP addresses, and similarly on R3. Now, once we've done that, we can ping from R1 a directly connected network. For example, R1 has been directly connected to. Just give me a minute so that I change my internet. I'm getting a notification that my internet is unstable. So let me change it to my phone. Okay, I think now it's okay. So from R1, we can ping the directly connected network here on R2, 10.0.12.2, just to confirm. So you see, we can be able to ping that directly connected network. The ping is successful. We can also ping the one that is connected to R3. This interface here that is connected to R3. So we ping 10.0.13.3. So if we do that, again, it should be successful from R1. The reason as to why we are able to ping it is because if we do display IP routing table, we should be able to see that all the directly connected networks have been added to the routing table. And you can see under the protocol column here, we have direct. So all this directly connected 10.1, 10.0.12.0 has been added to the routing table. Similarly, 10.0.13.0 has also been added to the routing table. And of course, the preference for directly connected networks is 0. So just a reminder from what you've already learned in the theory class. Now, after doing that, the next thing we are supposed to do is to go to step 2. In step 2, we are supposed to use the ping command to test the connectivity from R2 to the networks that are not directly connected to R2 on R3. So we are supposed to do a ping to this particular interface on R3 and to this external interface, which is the loopback interface on R3. So when we do that, what we expect from R2, so if I come here to R2 and ping an interface on R3, so we want to ping 10.0.13.3. Remember, this particular interface, if we can look at the topology, here, we are pinging, let me see if I can annotate. We are pinging this particular interface here, this one. So this interface is not directly connected to R2. So we expect that particular ping to actually fail. So let's try it. If we try to ping that, so you see, the request is going to time out because we are not directly connected to that particular interface. So again, similarly, if we try to ping the loopback interface, so we ping, is it 3.3? We try to ping the loopback interface on R3. We are not directly connected to it. So again, it's going to fail if we ping that particular loopback interface. Okay, so after that failing, now R2, if R2 wishes to communicate with the network segment, 10.0.3.0, which is the loopback, a route destined for this network segment must be configured on R2, and routes destined for R2 interface must be configured on R3. Now, this is what we call a static route. So the preceding test results have shown that R2 cannot communicate with this network and also with this network. And we can confirm that by running the display IP routing table. We cannot be able to get, if we run here on R2, display IP routing table, we cannot be able to get those networks, these two networks, this one, 10.0.3.0. We cannot be able to get them on R2. They have not been installed in R2. So that is what we want to configure now on step 3. So we want to create static routes to these networks, to that network from R2, and another static route to the loopback interface network on R3 to this network. So for us to do that, this guy here is going to be our next hop. We're going to configure this as our next hop. So that is what we are supposed to do on step number 2. So let's do it. As you know, when it comes to routes, routers can learn routes either through directly connected networks or through manually configured. Manually configured, that is what now we call static. And the last one is dynamically. Dynamically is when you're using routing protocols. Routing protocols, e.g. OSPF, that we just learned right now. So right now, we just want to configure a static route. How do we configure static routes? Directly connected routes are those particular networks that the router is directly connected to. So for example, R2 is directly connected to this network because this interface is configured with an IP address that is within that network. So that's a directly connected route. It's also directly connected to this network because this interface has been configured with an IP address that is within that network. It's also directly connected to this. So that is what we call direct routes. So direct routes will be installed in the routing table. But routes that are not directly connected, to the router must be configured either manually or dynamically, must be learned either through manual configuration or through the routing protocols. So right now we want to configure a route from R2 to these two networks. So how to do that? So in R2, so we go into system view, then the command is IP route static. Sorry, IP route static. Then you specify the network that you want to go to. So at first, let's configure this one. So we want to go to 10.0.13.0, then space, then the mask of that network. So it is /24, so we can enter 24. Then after that, you enter the next hop. So this time, this is our next hop here, G002 on R3. So our next hop is going to be 10.0.23.3. So that's our next hop.
I have a question.
Yes, please go ahead.
As you are assigning the IP address for static route,
yes,
when giving the subnet mask that is 24. /24, what is the difference when you use /24 directly or you type the 255 that way?
It is the same. It is the same. So you can use either. You can either use the long version or the shorter version, which is the number of ones in the mask. So thank you for that question.
Thank you.
Okay, so we also configure a static route to the loopback interface network. So the network is 10.0.3.0/24 again. Then the next hop is the same. So like that. So now if we do enter and do display IP routing table, excuse me, we should be able to see that we have an entry to the 3.3.0 network, which has been learned statically. The preference for a static route is 60. If we scroll down, we can also get the 13.0 network, it has also been learned statically, and that's why the preference is 60. All these other networks have been learned through direct, because they are directly connected to R2. So with that, once that has been added to the routing table, we can now be able to ping the loopback. So right now, if we ping the loopback from R2, if we ping the loopback of R3, which is 10.0.3.3, we should be able to get a reply because we've configured a static route to that particular interface. So let's go ahead and look at step 4. So step 4 is on configuring a backup static route. So how do we configure a backup static route, and why do we need to configure a backup static route? Okay, so just to explain to you what has been said on that particular paragraph, for redundancy and for backup, sometimes we need to configure a backup static route, because right now, let me go back here again. Sorry, let me clear and go back on here. If we do Trasat 10.0.3.3, we want to see when we ping 10.0.3.3, through which route do we go through? So you can see if we do Trasat that, you see that we are going to this router, which is router 3, which is the next hop, this particular interface here. So what if this particular link goes down? You see, we still have an alternative route that can get, for example, to this loopback, because R2, we can still be able to come through R1 to R3, then to this particular network. So if this goes down, then we R2 is supposed to use this particular route as the backup. So that is now what we want to configure. We want to configure a backup static route to this particular network. So how do we do that? How do we do that? Excuse me. As we learned in the theory, the default preference for a static route is 60. But if we want to configure a backup static route, we configure a route with a higher preference value, because the one with the lower preference value is the one that will be preferred. And therefore, it's the one that will be added to the routing table and used to forward packets. But if that one goes down, then we want this one to act as the backup. So on R2, we are supposed to configure this static route to the 1.3.0 network and also to the 3.0 network. By simply, what we are adding here is that, and also specifying the next hop. We specify the next hop as 10.0.12.1, which is actually the interface, that is on R1, this particular interface here. So let's do that first on R3, on R2, sorry. So let me clear. So here we do IP route static. Sorry, let me lift up something here. Then we want to configure to that network 13.0.24. The next hop should be the interface on R1 G001. So 12.1. Then we want to also change the preference from a default, which is 60 to 80, so that that one can act as a backup. So other than that, we also want to configure to the 3.0 network. The next hop and the preference are the same. So I'm just going to delete that one there, then enter. Now, if we do display IP routing table, we are not going to see that static route with a preference of 80 and with the next hop of .1, we are not going to see it. With the next hop of .1, we are not going to see it. Reason being, the best static route is the one with the lower preference, and there are these ones here with a preference of 60. So until this goes down, ndio hiyo yenye tumeconfigure itakuwa added. So I hope that is clear. So we are going to also simulate that in a short while. Now, we also need to configure on R1, we need to configure a static route to the 3.0 network because it's not aware of that network. You see here. So R1 is not aware of this network. So we need to configure a static route so that R3 can also be able to send a reply using this direction. Can also be able to send a reply using that direction. The other static route we need to configure is from R3 to this network, because R3 is not aware of this network. So we also need to configure those two. So let's go ahead and do exactly that. We can begin with R1. So at R1, we configure a static route. So IP route static to the loopback interface over 3, 0 to 4. And the next hop will be, of course, 10.0.13.3. So like that. Then on R3, we also configure a static route, IP route static to the 12th network. So 10.0.12, sorry, .12 .12.0 24, with the next hop being 10.0.13.1, like that. Good. So that is exactly what they have done here. That is what they have done here and here. So now let's test. We want to test the backup static route. If we do display IP routing table, as I've just mentioned, we are not going to get the one with a preference of 80. So in order to be able to do that, we already tested this. We did the ping, so that is okay. We already did the Trasat. We also did the Trasat, and we saw that if we are going here, we're only going to go through R3. So we now want to test the backup static route, the backup static route. So how do we do that? We need to shut down on R2. We need to shut down this interface on R2, G002. So to simulate the backup, we need to shut down this interface, this one. We shut it down so that if it wants to come to this network or this network, it has to pass through R1. So that is how we are going to simulate it. So let's do it. So here we simply do, we go into R2, then we go into the interface G0/0/2, then we do shut. So once we shut, you can see that that interface has entered a down state. And in the background, you can even see that it's turned to red. So we have shut that down. So now, if we do on R2, display IP routing table, enter. You can now see that the backup static route with a preference of 80 and the next hop of 10.0.12.1 has been installed in the routing table. Also, if you want to go to this network, the preference is 80 and the next hop is the interface on R1. So we're just simulating that if this link between R2 and R3 goes down, then R2 can still be able to communicate with R3 through R1. So that is what we call a backup static route. And you configure a backup static route by simply playing around with the preference value. So I hope that is clear. So the next thing we are supposed to do, so remember now, if we ping, I haven't done that, but if we ping the loopback interface 10.0.3.3, it should be successful. And you can also do trasat to see where it passes through. So you see, if we do trasat, we can see that it's passing through router 1 on that interface, then to router 3. So really, it's passing through router 1, as I've just explained earlier. Okay, so what's the next step here? We've done trasat. So the last bit, I think, of this lab is on default routes. Default routes. Default routes are used to tell a router that in case you receive a packet whose entry you do not have in your routing table, then forward it to this next hop. Forward it to this next hop. So that is really what default routes are used for. Now, this particular step 7, we are supposed to begin by re-enabling the interface that we had shut down on R2. So we go back to R2 int G0/0/2. Then we use the command undo shut to bring it up. So after we've done that, from R1, we are supposed to ping this particular network. And the expected result is that it should time out. And I'll tell you why. So let me come here. So from R1, we want to ping this particular network here. Remember, that network is not directly connected to R1, and we've not configured any static route to that particular network. But in this particular case, we want to use a default static route. So let's just confirm that from R1, if we ping 10.0.23, 10.0.23.3. So if we ping that, what happens? R1 is not aware of the 23.0 network. So it's simply going to time out. So we want to configure a static route, a default route for that particular purpose. Okay, so this one, they're just verifying in the routing table that indeed the 2.3 network is not in the routing table. It's not in the routing table of R1. Okay, so how do we configure the static route? We configure the static route like this. This is one of the application of the special IP address known as the Anycast IP address 0.0.0.0. So it is the Anycast IP address that is used for this purpose. So let's go ahead and configure this in R1. So we are simply telling R1 here that if you receive a packet whose entry you do not have in your routing table, forward it to this next hop. Forward it to this next hop. So that is what you're telling R1. So what's the command? The command is here. So in R1, we will do IP route static 0.0.0, 0.0.0 as the mask again. Then we tell it the next hop. So the next hop is 10.0.13.3. So if R1 receives any packet whose entry does not have on its routing table, forward it to R3 on 10.0.13.3. So if I do enter, now we should be able to, if we do display IP routing table, we should be able to see that entry. We should be able to see that entry in our routing table, the default route. So this is what is called a default route. It's also a static route with a preference of 60. And as you can see, the next hop for this default route is this. So earlier we were not able to ping the 10.0.23 network, but after configuring the static route, it should work. So you see, it works. So that is what we call a default static route. So I hope that is clear. So let's go on to the next step, I think. Step number 8. So we can also create a default backup route or a backup default route. We can also create a default backup route. So in R1, we want to create a default backup route. Why are we doing so? We are doing so because so far our default route passes through this link. But what if this link goes down? We are still supposed to be able to access this network. How? Through R2. So we're still supposed to come to R2 and be able to access this network. So we want to configure a default or a backup default route to play that particular role. So to do that, number one, we have to come to R1 and configure IP. Let me just use the history. IP route static, and this time we use the next hop on R2. So .12.2. So that's the next hop on R2, this Sky interface here on R2. So 10.0.12.2. Then you remember the preference. So now we do a preference of 80 because the default is 60 so that it can be a backup. So we do that. Then after doing that, we also need to configure a static route from R3 to the 1.2 network because R3 so far is not aware. R3 is not aware of the 1.2 network. So we also need to configure a static route to this particular network. So if we go to R3, and we do display IP routing table, there's nowhere we are going to see. Okay, oh, we have the 1.2. Let me see. Just a moment. Here we are 1.2. Okay, using that next hop as a backup. Great. Okay, now I understand. Okay, so we in R3 we have this particular route to the 1.2.0 network that is using the next hop of .1. But you see, that is the one that is going to fail. So we want to configure a backup static route to this particular network. And to do that, we are going to use the next hop of R2. So we do IP route static, then 10.0.12.0/24. Then the next hop is this one on R2, and we give it a preference of 80, like that. So after doing that, to simulate this, we will now need to shut down the interface on R1. So we shut it down. Then we validate that the backup default route has been added on the routing table. So let's do that. So really what we want to do is to bring down this link. We bring down this link so that the backup can take effect. So that's what we are doing right now. So let's go ahead and do it. So we're supposed to be in R1. So in R1, we get into interface G0/0, then we shut it down. Shut it down. So once we shut it down like that, if we do display IP routing table, we should be able to get the backup default route with a preference of 80 and with an X-top of 10.0.12.2. So I hope that is clear. So we can now test connectivity to from R1 to the loopback of R3. So we can do a ping to the loopback of R3 like that. And we can verify that it's passing through R2 by doing trasat. So trasat 10.0.3.3. So we can see that to get to this particular network, we are going through router 2, then router 3. And therefore, we are actually using the default, the backup default route with a preference of 80. So that is it about this lab. I don't know, does anyone have any question or wants to seek any clarification or a comment? Anyone?
I have a question.
Yes, please go ahead.
How can
Move
you
closer
filter
to
out?
your mic so that I can hear you better.
You can hear me now?
Yes, loud and clear.
Okay, I have a question.
Please go ahead.
Assuming you want to filter out IP routes learned from specific protocol or maybe
Yes.
route static routes. So which command do you use? Like for example, IP route and then the following from you learn you want to show the those
Okay.
routes only from specific protocol or either static you understand?
Are you talking about showing routes
Yes.
that have been learned through a particular protocol, or are you talking of filtering a
Yes,
route?
filtering.
Okay.
Okay. Just go back to maybe where you showed the routes, maybe learn from static or direct.
Okay. So display IP routing table.
Yes. So now this column for protocol is static
Yes.
direct.
Yes.
Assuming there was some routes learned from maybe
OSPF.
OSPF, BGP.
Yes. Hello?
From let's say OSBF, I will be
Yes.
able to filter out. Yes.
So you want to see routes that have been learned via a specific protocol?
Yeah, without displaying all these
Okay.
the ones.
Okay.
Let's say, for example,
I
direct.
think the command is display IP routing table. Then you can specify a particular protocol, if I'm not wrong. Display IP routing table. Protocol. Yeah, you can specify a particular protocol. I don't know if it can do static. It's like it can do static, but if we had configured, for example, OSPF.
Okay, before that, I think the way you do it is let's say display IP routing table and then protocol and then you write the name.
Okay. Okay. Yeah, there's actually a command to do that. It's only that
okay,
I'm forgetting
it's only that I'm seeing here that the possible completing maybe inputs which should be, for example, the first one is IP prefix, limit, protocol, blah, blah. So could you maybe type display IP routing table and then write protocol? It's okay, for example, direct.
Oh, yeah, exactly.
Protocol direct.
Exactly.
Yeah, something like
Thank
that,
you.
yes.
Yes. So we can do static.
Yes.
So that we can just produce just routes that have just been learned through the static routes. Yeah. That is it. Oh, thank you very much. I think I had forgotten that bit.
Okay, thank you.
Okay, so asanteni sana.